Hello, in the previous video on Kirchoffs laws, we found that Kirchoffs' first law, which was the current entering the junction equals the current leaving the junction, i.e. if this is a junction and we have some currents here, if that was 5 amps going into the junction and this was 4 amps leaving that way, of course, conservation of current, conservation of charge as such, is that must be 1 amp. 1 amp. So the total current entering the junction must be equal to the total current leaving the junction, and that they could be negative currents as well. Now, Kirchoffs' second law, that was the first law. Kirchoffs' second law is that the sum of the EMFs in a closed loop is equal to the sum of the potential differences in the components. So we're going to look at a more complicated example here, which will involve eventually simultaneous equations. Okay, so let's take a more complicated situation rather than just one simple loop, as I showed you in the previous example. So let's start with a 6-volt cell here. And we'll have a parallel circuit with a 30 ohm resistor there, a 10 ohm resistor there, and in fact what we'll have here is we'll have another EMF acting in that direction there, which in fact would be opposing. So we then start off looking to a closed loop. So we're going to look at closed loops here. So one closed loop we could look at this closed loop here, and let's put on some currents. Maybe that's I1. This is I2 there. Oh no, let's do it more like the example follow. Let's call that I3, and we'll have a current going in this direction, I2, because currents can enter junctions from opposite directions. So what we'll find is we can now have a look at what's going on. And of course, if that's I1 there, that must be I1 there. And if that's I1 there, of course, we're going to have that's I3 there. This, in fact, here must be I2. Okay. Now, if we look at the junctions first of all, if we look at the first Kirchoffs' first law, we'll see that we've got two junctions. We find here that I1 plus I2 is equal to I3 in this junction here, and this junction here we have I3's coming in, I3 splits up, and those two direction there is equal to I1 plus I2. So that's reassuring. Now we've drawn our currents going in the correct direction there at those two junctions there. That one applies to there, and that one applies to there. So that's the first law here. That's one set of equations. Now, if we create, let's go for the first closed loop, which should be the top one here. We can have, well, the sum of the EMF. So we've just got one EMF in that closed loop there. We can have 6 volts must be equal to, well, because we know that V equals IR, an expression from Ohm's law, we'll know that, so 6 volts here in this closed loop here, well, there's a drop there and a potential drop there, or potential difference across there and a potential difference across there. So here we have 6 volts is equal to IR, so that's 30 times I3, 30 times I3, plus here we have that bit there, so that would be 10 times I1. Then we can label this, if we like, equation 1. So that's one loop there. Okay, and another loop we could have will be, and again we go positive direction here, we can have this loop here, and that's equation 2. That would give us 2 volts, must be equal to, again, 30 times I3. So here we have, that is that loop there, and previously this was this loop here. Okay, so that's 30 I3. Okay, and from there we've created 2 equations, but also we could combine that with maybe this equation here. So we've got 3 equations and 3 unknowns, so they can be solved simultaneously. Let me try and spell simultaneously correct. So they will form simultaneous equations, and that will give us our values. I won't solve those right now, but that just shows you the more complicated way of applying Kirchoffs laws to examples.